In today's lead code, we are going to look at maximum score from removing substrings. So here you have two choices. You can either remove AB, which would yield you X points, or you could remove BA, that would yield you Y points. So you can choose one of these operation, and at so you can choose which operation you want to perform, but the end objective is to get the maximum score possible. So let's look at our example. I'm going to pick up only the last four characters because that's the interesting part. Here, if I remove AB, I get 4 points, my x is 4, and if I remove BA, I get 5 points. So in this string AB, I have two choices. So in this string AB, I could either do AB and then again AB. This is my first choice. And the second choice is I could do BA, and then with what is left I can do AB. So these are the two choices that I have. And when you look at when this second case where I have AB, when I remove BA, I'm left with AB, which is still valid. So from this I can say that I care about the last available item, like whatever is not processed yet and which is available for me to form a substring. I only care about that. So I am looking at the last item in my list. So when I want to look at the last available, this means that I can use stacks. So I go character by character. When I find a match, I can remove my last character and I can continue to do that. So every time I see a character, I can look at the last available or the last unprocessed item. So for doing that, I think stacks are a very good data structure. So here, how do I choose between these two? Should I just pick the first match that I get, or should I go with greedy? So why greedy works? Why greedy works? Let's look at both the cases. AB, this would yield me 4 points here and 4 points here. In this case, if I pick BA first, this would yield me 5 points and this would yield me 4 points. Here I can say that this gives me 8 in total and this gives me 9 in total. So why this works, like why picking the higher value works, why greedy works? One, we are dealing with only two characters, so there are no overlaps. So between substrings there won't be any overlaps. So if we were dealing with three characters, we might have overlaps and greedy might not work. And here, when we do take away greedily the substring which yields more points, we do not remove the chance of forming available uh, pairs after removal. So not affecting available pairs, because we have only two characters. If there is a pair, it will eventually form a pair. So if we greedily pick up the maximum point, so we will get this point and we will get what is left. So that's why greedy works. So yeah, these are the two key concepts. One is we have to use stacks and other we have to pick greedily. So to solve this, first you can have two iteration. First iteration going through the whole string and taking off all the substrings that yield you more points, and then you can go for your second iteration and remove the substring that yields you fewer points. So you will have two iteration. So what would be our approach? So what would be our approach? So we would remove high value substring first in our first iteration using stacks, and then we can remove low valued substring, and finally we keep track of the total and return the total score. And for the code, I have a helper function here. I pass in a list of characters that are left in my string s, and what is supposed to be my first character of my substring and what is my second character of the substring, and what is the score that I would get when I remove these two characters. So as we already discussed, I'll be having a stack and the result will keep track of the score that is accumulated. So I would go through the string list, and if the stack is not empty, and if my current character is the second character, and my latest item in the stack is the first character, which means I have found an ideal substring, and I can increase the score, increase the output result by the score. And I would remove the most recent item because I've already picked it up as a substring. If not, I would add it to my stack. Eventually, I would accumulate all the score based on what I have removed, and I can return the updated stack. So this is my helper function, and here based on which is higher, if x is higher I would give priority for AB, and if y is higher I would give priority for BA. That way I can find the score for removing AB and BA. So this would yield the right answer. So for the space and time complexity, in terms of space, we need to keep track of the stack, and this stack can grow as big as the string in worst case situation. Um, and we iterate through the whole string list. So the string list is nothing but the string and then modified string. So the length of the string is the time complexity. And we also have uh, converting the string to list. This is also of order n, and we have multiple calls. So we have two calls, we either do these two or these two, so that again would be order of n. But since we add order of n plus order of n plus order of n, it would come down to order of n. So the space and time complexity is of order n.